Hello, everybody. Very good morning, evening, or afternoon, wherever you are. Delighted that you're all joining us today, either live or on demand, for this really important webinar looking at management standards for AI. Delighted to be joined today by Rob Claxon, the Chief Researcher from BT, and John Kivora, the Thought Leader for Cloud and AI from IBM. If you go to the next slide, please. So just a little bit of introduction to me before I hand over, firstly, to Rob. So today we're going to be looking at workstream 2, which is looking around the work of management standards, looking at the work the forum's doing in creating those standard interfaces and standard component structures for really managing AI at scale, and understanding really what challenges AI brings to operating on a network really at scale. This forms part of 5 work streams that we have here at TM Forum. The first one looking at a data model to support the requirements of open digital architecture to support AI and machine learning. Also, we have the third work stream that's looking at the training repository for AI, so it looks at what those data requirements are, and looks at creating a safe environment so that we can test out models in our open digital labs. The fourth work stream that we've developed is the AI maturity model, allowing service providers to really assess their AI on maturity and how they're going on that journey. And delighted to say that the maturity model will be ready in time for TM Forum Live, for Digital Transformation World now, which will take place in Nice. I'll talk about that at the end of the webinar. And now is in the state of being validated and will go live in time for that event, as well as looking at creating the 5th work stream, AI user stories and guidebooks, which brings together all those other work streams we've got coming together to look at some really detailed use cases, story maps, and workflow diagrams to look at where we can really now start to implement AI. So with that, I'm going to hand over to Rob, who's going to talk a lot more about managing AI at scale. Rob.
Okay, thanks very much, Aaron, and hello to everyone who's joined us. So I'm just going to kick off. It's going to be me, and as Aaron said, in a little while, Janki's going to take over. And we're going to take you through the work that we are currently doing as part of the AI management standards in TM Forum. This image here is just to try and illustrate the richness of the space, I think, that people are looking at addressing with machine learning and AI. So it's spanning everything from customer interactions, conversational chatbots, through to network management and optimization, and right through to marketing operations and how ultimately we operate 5G networks as they come down the line. So there's a kind of smorgasbord of opportunity, I think, and no small amount of hype and genuine interest as well in trying to use AI to run our businesses better. And then a set of concerns, I think, across the board. And of course, in some cases, the way we end up deploying machine learning and AI is going to be pretty benign and maybe small scale, but the issues really start to emerge when we are doing things that really matter to people. They're properly going to get noticed when they go wrong, or there's a lot of focus on them. And then when we're doing that at scale and keeping a grip of that and keeping control of that is going to be difficult if we don't do it purposefully, and that's what we're trying to do within the AI management standards work, and we'll try and take you through some of that story today. But the broad message is really that we need to do this deliberately, and in many cases this is going to take a change of approach from businesses to do it successfully. It's not going to happen by accident. In fact, if we let it happen by accident, what we're going to have is lots of accidents, and they're not going to be very pretty. So we need an approach across the board to be able to use and deploy and govern AI successfully, and that's what we're about. And that means considering the people in the business and the skills that they've got and their understanding, the culture and the processes that underpin that in terms of how we manage AI, and the data and increasingly the models and so on that fall into that bucket, and how we look after those across the life cycle. Those are all going to be big considerations. So just to try and sort of stretch the thinking maybe around what does managing AI actually mean? What does it look like? What are some of the scenarios we might come to need to take note of? I've got here 3 hypothetical scenarios just to take you through. They are straw men really, so you can throw sticks at them and things like that, But the idea is they kind of stretch the thinking a little bit about what it means to manage AI properly, what could happen when things go wrong. So the first one here is takes the sort of canonical example of using AI or probably more likely machine learning really for doing some sort of credit checking application. And suppose a business has built such a model, and actually they've deployed many instances of it. So they've got many variants of it across their enterprise. And at some point down the line, and I said 12 months here, but just what we mean there is a sufficient amount of time really for people to have maybe forgotten a little bit about how that model came into being. But at some point down the line, it becomes known that the data that was used to train that model has been poisoned. So in some way, someone's got hold of some fraction of that data, they've manipulated it in some way, and now they're able to force an incorrect classification from that model. So they're able to control its performance in a way that we shouldn't have had happen. So what does that mean for the business? Well, what you'd want to be able to do in that situation, obviously prevent it in the first place, but having had it happen, how do we actually find all the affected models? Which are the models in the business that use that data? How can we get that traceability across the life cycle to make sure that we know we can identify all of the relevant models that touch that data and therefore might have been affected? Can we actually detect that any of the models have been attacked? And that means have we got a good enough audit trail of what the models have been doing once they've been deployed to know whether or not something's been attacked? And then subsequently, can we identify who's been affected, which customers have been affected? How do we go and, can we then go and find them, correct whatever's happened, and then demonstrate that we can prevent future occurrences? So that's just sort of one scenario, and that really speaks to being able to understand the provenance of the data that comes into models, and then how those models get built, and then being able to trace that right across the life cycle. So this is scenario 2. We've got a telco, it's using AI to optimize operation of its 5G networks in the future, and then there's a big outage, and this is affecting communications nationally, and maybe it's involving it has an impact on emergency service calls and those sorts of things. And perhaps it's expected that there's a malicious exploit at the bottom of this outage, and AI systems that have been deployed in this scenario, someone's found a way of exploiting them. And now we've got very serious attention from government and regulator demanding an explanation for the outage, and then also demanding that we can demonstrate that we've actually got appropriate control in place to in the future ensure that we've got safe and correct operation of that network. So now we've got to be able to make the case that says we are managing this stuff properly. We can identify all those model inputs, the training data, anything that was used to create the model, so we know it's safe, and we can demonstrate how it was tested, what sort of testing was this model subjected to actually then say yes, it's ready to go into production. Can we show proper governance across that life cycle? A proper sort of process for accepting the model into service and then being able to trace it. So when we point the finger at the model in live, we know how that came into being, and we can track right back through its history. And that we maintain a chain of custody, again, right across that life cycle. Who did what, when, and how. And so there's a whole bunch of considerations there that we need to know that we're going to have the mechanisms available that we can actually demonstrate to external parties in this case, that we are in a position to actually govern this stuff properly. And this final one's just slightly different, but just to sort of put a different spin on things. So put yourself in the position of being a data scientist. You've developed a chatbot, and originally you intended this chatbot just to be used for internal use. It wasn't meant to be in front of external customers, but it's out of your control now, and a different team has gone and repurposed your chatbot, and they've actually hooked it up, and it's sitting on an external website, and it's handling customer inquiries in some way. And this is a problem because you just thought it was going to be used internally. The data that was used to build the chatbot wasn't properly cleaned, and it turns out it's possible to provoke it to reveal some personally identifying information. And so now you've got, if you're in the UK, it's the ICO, the Information Commissioner's Office, they want a word, and obviously other regulators in other jurisdictions. And the finger is pointing at the data scientist. You know, why did he or she develop that chatbot in such a way that this could happen? And of course, they didn't want it to be used in that way. So the question here is, how can a data scientist make explicit the limitations on their model, in this case that it shouldn't be used externally, and make sure that those limitations are attached to that model for its lifetime, so that anyone who chooses to use it outside of that that specification knows that it's not warranted for that case, and the data scientist is protected, and the business also knows when it's pushing the boundaries, let's say, in terms of the use of given models. So that's just a slightly different scenario. So these are all intended as kind of provocations, really, to sort of address this question, well, what's the harm really around deploying AI? And hopefully that's sort of helping people think a bit more broadly about the different scenarios we might find ourselves in. And ultimately, what we want to do with the AI management work is get a grip of this stuff early on, so that when we build out our AI infrastructure, you know, it maybe looks a bit like this picture rather than that one. What we want to do is to do this in a deliberate and a managed way, so we maintain governance and we don't have to go and sort of look at that mess on the right hand side and unpick that at some point in the future. One of the questions we quite often get when we're talking about AI management is, why is it different from managing IT generally? We've been doing IT management for a long time. We've got a lot of skills around procuring and deploying IT systems. Why is AI any different? So I wanted to try and address this, and this is how I've done it. Of course, there's a lot of good practice, really excellent practice, that we can build on, and we should do, and I hope we are doing in the work that we're undertaking in this work stream. But my argument is that there are sufficient differences between our sort of traditional IT and what we get in the AI world to make us sit up and pay attention and do some different things. And the one way of thinking of it is that you could think of your traditional IT as being a bit like this soft toy dog in the top of the picture there, versus your machine learning and your future AI looking a bit more like the live puppy at the bottom. So on the face of it, they look pretty similar. They're both dogs, but they've got completely different types of behavior. So the soft toy obviously has very limited capability, and importantly, it doesn't evolve. Once we've built it, we know what's going to happen to it. We can make really strong predictions about how it's going to behave, and we can inspect it. We know, you know, from one moment to the next what's going to happen when it's subjected to certain inputs, if you like, versus the live dog, which we can train. We can get it to do things, and more or less does what we hoped it does, but ultimately it remains opaque. The model that's inside its head is not directly inspectable, and it's evolving and it's learning and it has autonomy. And so I think these are some of the key differences. And then we couple that together with the fact that our AI systems are going to become composed, they're going to become connected together, and we're going to build them out at large scale. And there's a strong regulatory and ethical focus around AI at the moment that I think is shining a particular spotlight that we ought to be cognizant of. You know, the general public doesn't necessarily see AI as a as a straightforward positive thing. You know, there are some negative associations with that we have to be aware of. So I think for all those reasons, AI does deserve, certainly today, special treatment in the sense of making sure we can manage it properly. So where are we trying to get to? So this is an attempt at a shortish version. So we've got the sort of doom and gloom of those hypothetical scenarios, and we've looked at why AI is perhaps different from our traditional IT. What does it actually look like? Well, here's the sort of scenario today where we might end up deploying AI systems and models from multiple vendors across an enterprise. So lots of different technology types and lots of AI types. And each of those are going to end up with some kind of management functionality associated with them, but it's not going to be consistent. So whilst we might be able to sort of manage them individually, it's going to be very difficult to get a view across the piece about what's going on and to know that we've got sort of good, effective governance across all of our estate. And we could do a job a bit like this. We could say, well, let's just sort of hook into some of those underlying capabilities. We'll do a bespoke integration, lift out information and control from those individual systems to the enterprise level. That is obviously going to work to some extent. It's going to be a lot of work. We're going to have bespoke integrations, and there'll be no consistency. So we're never going to really end up with that across the board picture that we want. What we're really trying to get to is this. where we've got some consistent interfaces, those are the red blocks, that are hooked into our enterprise AI governance sort of overlay. So across all of the different vendors, whether it's vendor solution or in-house built, we've got some standards to adhere to that will expose both information from those systems, but also expose control, and do that in a nice consistent way across the piece. But we also acknowledge that in each of those systems, there will be components, that we could loosely call management, that we don't need to know about, we don't need to inspect or to hook into. So the part of our challenge is getting the balance between figuring out the bits that we need to expose versus what sort of stays within the stack itself. And this is the sort of view then across the whole of the AI lifecycle of some of the considerations and the concerns that we might have, and that we're sort of folding into our work in terms of what we want to be able to manage and have visibility of. So from the left to the right, when we're building models, it's a very iterative process. We go through many versions as we try and develop an AI system. We ingest lots of data, we borrow model weights from other pre-existing models and word embeddings and things like that. Really important that we know where all of those things come from, where those inputs are, and then how that model was actually built and tested. What do we do to verify that it was valid and it was in a sufficiently good state that we could actually then go ahead and deploy it into production? And obviously, once we're into production, there's a bunch of things that we're going to want to do around all of our AI systems to make sure that we maintain that governance. And particularly, we want to know that the model is still valid. It's in the nature of machine learning and AI typically that we constantly need to retrain. Knowing when to retrain is obviously very important, but knowing when the model has drifted and that things are starting to go wrong, obviously, so that we can prevent problems is key. And there's all sorts of ways that might happen. I'll come on to that on the next slide. And then finally, at the right-hand side, when we retire our models, we take them out of production. We don't necessarily want to forget them then, because we want to maybe preserve information about them so that we can learn what went well and what didn't, and that we've actually got an archive, perhaps for regulatory purposes, about what actually happened. And then in terms of that in-life piece, that piece around production, just to drill a little bit more deeply into that, we really care about things like data quality and the validity of the input data into our models. It's quite normal, well, we've come across it many times where models are built and then we've not got sufficient monitoring around the quality of the data going into them, or something about the data changes that would make the model not valid anymore, and then nobody notices until there's a big problem. So actually having a good handle on that is obviously key. And equally on the output side, are the models performing in the way that we expected them to, based on what we saw in training? And if they're not, that's a clue that we need to go and look at them. We should be alert to that and go and fix whatever's gone wrong. So a whole set of things around making sure that the inputs are valid, that the output is expected, and then that the dependencies on the model are satisfied. So, there are going to be lots of things in the environment around these systems that they kind of implicitly depend on, but they don't necessarily know about directly. And that's a case where the AI management piece can step in and help forge that link, make sure that stays there. So if something changes in the environment, makes the model no longer valid, we know about it and we can then go and take action. And we need to do this, obviously at the level of individual models, but perhaps more importantly, at the level of the systems that become composed, and then across the enterprise, so that we can demonstrate good governance. So that's a kind of quick run through of some of the sort of vision and the philosophy around the AI work. What I want to do now is hand over to Junkie, who's going to take us through, I think, hopefully a live demo around that will bring some of this to life in terms of the capabilities of systems that we have today for building and managing models. And Jankie's going to take us through that, and hopefully that will give you a bit more context around what we're trying to do. So over to Jankie.
Junkie, we can't hear you. Sorry, I think you're muted.
Okay, is it better now? Okay.
We can hear you now, yeah.
Perfect. Thanks, Rob. So what I'm going to discuss now is through a live example, demonstrate some of the challenges we see with our AI systems, and ask TM Forum what we are trying to, what kind of work we are trying to do. Up here, I'm going to tell a story through Clara, who is our character, who is a client executive responsible for, managing churn and, making sure that the customer satisfaction is managed well. But as you see in this case, Clara sees that her company is facing an increasing rate of churn, and the Net Promoter Score is also dropping. So she goes to her AI team and goes to Rob and says, "Hey, Rob, I don't know what is happening. Why is the churn model, is it working fine? What is going on with that?" Rob takes about 2-3 weeks to come back and deliver the grave news saying that, "Hey, Clara, our churn models are not accurate anymore. In fact, we are making wrong business decisions because of that. And it took me so long because the data that was used to build this model was sitting in the data scientist's laptop, and I think the data scientist no longer is with the team, and it was hard for me to gather all of it, understand what was happening with the model accuracy." And not only that, we are also losing a lot of revenue because there has been bias introduced in our model, and we are not making the right kind of offers. This is just a scenario and related to churn, but we know that for telcos, we are dealing with a variety of AI use cases, just that Rob illustrated. We have to, AI is important for our network analytics, AI is important for, our automation, and AI is important for a variety of use cases. But this is just an illustration, and I hope you can connect with that. With that, I'm going to go ahead and demonstrate the live, the scenario. This is again an illustrative, no real client data, is just, used synthetic data and a dashboard that I've put together with my team here at IBM. And what you can see is the customer 360 dashboard. And each of these widgets are fueled by various models, both trained on structured, unstructured, streaming, and different types of data sitting on multiple clouds. And up here, I would like to draw your attention to, we see that this customer, Paul Kelly, who is a millennial, is at a high risk for churn. And we have our credit risk model has also identified that this individual is at a high, is very risky. And what happens is, for that reason, we're not making a good offer to Paul Kelly. Now, going back to a variety of other things, we know tone analysis and, taking unstructured data, being able to, identify various tones is being seen here. And when we talk about it, we have to be mindful that, each of these models have to be, built on a variety of data. And, as working on this management work stream, it was, a good collaboration to see how variety of AI models have different kinds of, things and aspects that we have to be mindful of, not only from tooling perspective, but also from, how we manage and process and, governance around these things. So we've put together ideas and things and requirements around that as well. Additionally, what we see here is a deep learning model, and deep learning models and other AI models are also thought of as black boxes. Up here, we have, built this model on a lot of unstructured data, and then the deep learning model is giving a summarization. But often we want to understand, how do we, manage as we work with our, various data scientists, how do we manage the lineage and provenance of our data and models? So up here, you can see that this is, again, a platform, the IBM's AI platform, where you're able to catalog data from a variety of clouds, sitting on third-party clouds or behind your firewall. And rather than what happened with Clara, where Rob, who was having a hard time finding the churn data set because it was sitting somewhere, data should be accessible and cataloged so that you're able to reach to that data set. So up here, just based on keywords, You can tag those data sets so they are, following the common language for, your business and is able to, be able to be searched easily. So rather than, trying to spend too much time finding data, we have tagged it and being able to identify that data set very quickly and easily. When data is made searchable, we also want to make sure that it is governed correctly. So in this particular case, the churn data set, you can give conditions and make sure that only right individuals have access to the right kind of data. And often you want to have, let's say your network team share the data as long as it is governed correctly and is within compliance, share it with your marketing team and by anonymizing it or redacting it and masking it. So ability to, so that the patterns are still intact, but you're able to securely share data amongst various lines of business within the company is important. So the AI platform is able to do that. And when we talked about, and this is a little bit taking under the hood. So as you see here, as a data engineer, and I'm a data scientist myself, where often I get data sets from other team members, and I'm like scratching my head, like, okay, what was done? What this allows you to do is it automatically is, sort of preserving all the steps that you have taken to transform the data. So when you share it, I can understand, or another data scientist can understand what was the lineage or what were the changes that were made to the transformation. And then I can have more confidence in the data. Understanding, the lineage of the data. So, what was up here, as you see, anytime the data is touched, a record is logged such that you can identify, what changes, what was the profile, what was, the transformations that were made, and it was changed or it was, updated by which data scientist. So this allows you to log not only the time and the date when it was done, but also all the steps. It's almost keeping a record for all the transformations that you're making through the data to get back to it and query it as to what was done. And not only should such provenance be made available for data, but also for the data models. So for example, this propensity to call model should have a description or a signature saying that, oh, this propensity to call model is primarily to be used for evaluation of Q length and not for net promoter score. So what, Rob was talking about, that, there needs to be a signature covering the data scientist in terms of, what is the usage of this model and is it being used in the right way? There should be ability to understand the lineage. Where are the various data models, deployed, and getting a quick view for that is important. So this is, talking about not only about development, but there is another phase, which is operational, right? Once you have developed your model, you want to deploy it. And what happened with Clara was, her business started to have impact, and that's when she was able to understand that maybe there's something wrong with the churn model. Rather than that, there should be a quick way to, get a health check or a scorecard for your models, understand what is happening. So these are various models, and as Rob was mentioning, they could be sitting and being using a variety of technology, a variety of vendors, but a way to quickly understand what it is. And this is, just one of the vendors, in this case, IBM, Watson OpenScale, showing a report of your model and being able to understand that my accuracy for the model is 58%. It's really poor and it has dropped. And, that is very natural that, when you deploy and operationalize a model over time, the accuracy often deteriorates. But you need a mechanism to be alerted that, it has dropped and you need to take action and, you need to redefine it, redeploy it. And the another is making sure that your models are fair. One of the reason is for compliance and governance reasons, and GDPR reasons, but also making sure that you're making the right business decisions. So in this particular case, what is happening is we see that there is a flag or an alert that there is a bias identified in gender and age for the model, for the credit risk model. that is in operations, we're able to understand each transaction, right? Various transactions that are being made, what is the utility of my model, and how many requests are being made. All of that information should be logged, and we should be able to get back to it, understand the implications of each transaction that is happening continuously during runtime of the model. Let's say we very quickly identified that there is bias in age, where the millennials are being flagged as high risk candidates. And for that reason, there was a recommendation made by the Watson Open Scale saying that, hey, we have a model which is 80% more fair. And in this particular case, we see that, a debiased model is much fairer, and you can automatically deploy it as well. But having said that, during operations, tying it back to where I started to tell the story about Clara, we see that once the debiased model is applied, Paul Kelly, who is a millennial, initially his churn risk, he's still at a high risk for churn, but we saw that the bias had creeped into our model, and we were flagging him at high risk, but now we are flagging him as no risk once we debias the model. And we are also making a good offer. First, our next best offer was, no offer was being given to Paul, but now we understand that he's not at risk, he's a millennial, and there has been bias. So we are now starting to make good offers to him and, increasing our chance for retaining it, Paul. So as you see here, it is important, to make sure that our models are fair, not only for compliance reasons, but also making sure that you're making the right business decisions. Additionally, we need to know, AI should not be a black box. It needs to be explainable, right? In this case, we are seeing that, for a particular candidate, whether an offer was made or not, and if an offer was made, what are the key variables or factors that were assigned that were taken into consideration for making that offer. And, it could be similar for any other model. If it's a credit risk model, was he denied because, and if denied, what were the reasons? There needs to be an explanation. So if Paul or someone comes back to us, or, there is, for GDPR purposes, we need to explain why a decision was made. It's helpful to understand, and it's just not mere black box, but you're able to understand and trust your AI systems. Finally, this is just talking about some of one of the vendors, that's IBM, but there are other vendors and also open source technologies that are that need to be part of it. So IBM has made a lot of debiasing models and other models available as open source that you can use, and this is just a sample AI Fairness 360 toolkit that is available. And as I was, as I started off earlier mentioning that this is, just churn is one scenario, but let's say as we talk about 5G, AI is becoming very important, and it is very critical that we are able to manage AI at scale, because now your models are not only going to be, one or two models that are going to be running into the business, but once you build a model, they're going to be deployed on very intelligent devices at the edge, let's say a Raspberry Pi or NVIDIA graphics card, or, for autonomous vehicles, you have those cameras that you are controlling and managing those thousands of AI models. So now managing AI models is very critical. This is, you also have to manage it from risks like attacks. So up here, this is a simulation. How we can see that at this point, with the level of confidence, once you start, adding noise to these various things, the confidence level of, predicting a particular, because now it's an adversarial attack that can happen to, and this is just a scenario where, let's say it is autonomous driving, and instead of the stop signs, because of the adversarial attacks, now it's going to convert into yield signs, it would be very catastrophic. So how do you manage those thousands of models, understand the provenance of those models, and then take action in real time is becoming very critical. So I just wanted to share some of the examples here and hope it was helpful. With that, I will hand it off back to Rob to take us to the next section.
Okay, thanks very much, Jenki. I thought it was an excellent, it was really good to see it for real. I think that was quite important to see the capabilities that are built into tools like that. And also, I think really good to draw out some of the issues that you mentioned around things like adversarial attacks and as we talked earlier about sort of data poisoning attacks and things like that, that really kind of underpin the importance of being able to track where data is coming from, all the training data and so on, and how models actually got built, so that we know that A, they're going to work, and B, that from a compliance and governance point of view, that they're safe. So I think there's a lot of existing capability in tools like that, and I think the job that we've got in TMF is to figure out what of that has to be exposed, or we can usefully expose across the piece, because recognizing we're going to be in multi-vendor, multi-technology environments. It won't just be all within one stack, and making sure that we expose all the right bits and leave the other bits behind, so we're not duplicating lots of functionality and basically getting in the way. So I think that's key to what we're trying to do, to make sure that we're doing useful things, that we interwork with the right functions and so on. And that piece across the board, I think that where we want to plug the gaps that the tools like you just demonstrated, maybe there are some governance gaps in there, or things that they can't do on their own. And there's an example of that here, if I can just get control of my PowerPoint again, which I'll just quickly talk to around what happens as we start to scale AI in our businesses. And what happens is that models become potentially composed. So what do I mean by that? I mean, if we've got 4 AI models here, with each with an identity, and perhaps when they were built, the expectation was they operated independently. They didn't talk to each other. The outputs maybe go to a human or something like that. So they're not connected. But over time, I think it's inevitable that we'll actually see these systems become connected, sometimes deliberately, and sometimes perhaps accidentally, or without the kind of oversight that we'd want. And that is potentially going to be a problem. It might be the case that it's just not appropriate to have one model feeding into another model, and that automation there without any kind of human supervision. So from a business point of view, across all of the AI piece, we want to have visibility and sight of that. How can we do that? This is just an illustration of what we might do. So in this case, what's happening is as each model operates on some data and then spits some results out, they get tagged with the identity of the model that did that work. So that this model here, model 12, has tagged its data as coming from model 12. And when we see that tag as an input to another model, we know that they've become connected in some way. So we can start to recover the topology that exists amongst these models, and detect when models have become connected, and then check against the model policy that we've put in place, that's part of the AI management standards we're developing, that says, is that appropriate? Was that the intended situation that we were happy to cater for, or is that a problem? We need to go and do something. And then as each model becomes connected, that tag of model identities grows. So in this case, now we've got models 12 and 56 mentioned in the data that's coming into model 78. So now we know that link exists, and so on. And so we build up the topology across all of these models, so we can understand who's connected to whom and check whether that's actually appropriate. And the idea is that even if we can't see the whole picture, we can query individual models and say, what can you see? What is upstream of you? So we can get at least a partial view of the topology that exists, and therefore at least go and operate on those bits that are visible, if not the whole piece, which we're probably unlikely to get to. So that's just an example of what some of the pieces where your standalone management around a particular vendor isn't necessarily going to be able to help you with those sorts of problems, and that's a sort of example therefore where TM Forum has got a role to step in and try and suggest standard approaches that will help alleviate those sorts of problems. So that was a sort of, we've done this sort of whistle-stop tour of all the issues. We sort of provoked hopefully some thoughts about why we need to do this, why managing AI is going to be a little bit different from IT. What does it now all look like in the context of the work that's actually going on within TM Forum? So I'll just take the last sort of 5 minutes or so just to quickly run through what's actually going on. So in the previous release from TM Forum, release 18.5, We've done a lot of work around this thinking, which we're sharing with you today. The way it started off looking, and this is still a kind of high-level model to help people understand where we're trying to go, is this image here, where the idea is we've got some AI system, and it could be anything from a chatbot through to something doing network optimization. What we're trying to define as standards that work in as many of those scenarios as possible. They're not restricted to one particular type of AI. And the concept is that we wrap around that some lightweight interfaces that can be implemented as appropriate to support the management standards. And we recognize that maybe not all of those interfaces will be necessary in every case, but by stipulating or by providing those standards, we can get some consistency in terms of the information that's exposed from these systems and the control that we get over them. And so where we began was thinking about the ability to audit models, to exert some sort of policy control over models once they're in life, to get snapshots across the life cycle so that we've got that traceability. And eventually, maybe into areas like explainability of models, and be able to get an explanation from a model about why a particular decision was taken. Although I think that's still a hard topic, even in the academic world. So that's maybe a bit of an ambition there. So that broadly, the idea is that we wrap around these lightweight interfaces and then implement them as appropriate. And this is just a view again across the life cycle, from developing a model through to eventually decommissioning it, of some of the data entities that we're starting to surface. This is a bit of a simplified view, but just to hopefully gives you a picture of the kinds of things that we're looking at in terms of being able to capture, to persist either in the vendor's solution, or to lift out of that into the sort of TM4 management layer, if you like, and some of the data entities that are associated with exerting the controls that we think we need. So you can see in here all the sorts of things that Jenki was talking around in terms of model provenance, being able to capture the inputs to models, all of the training data or the results of training runs, so we can actually validate that we tested it in this way, and this is why we decided it was appropriate to proceed. We can preserve a model warranty that's an output of the development phase, and then we go into actually commissioning our models. And then there's a purposeful step there that says, right, what do we need? What are the steps before we accept this into a sort of operational environment? Let's get a snapshot so we know what it is we're actually deploying, and what's the kind of policy that we wrap around that to make sure that once it's live, that it continues to work correctly. And there's all sorts of policies that we might want to, or controls and tests that we might want to do in life to make sure models are working properly. And a couple of examples just of different types. On the one hand, we might say the policy for this model is that you never compose it. In other words, you don't allow its output to be fed into another model without some further design and testing taking place. And if we know the topology, or if we can recover the topology of our AI in life, then that's the thing that we can actually test automatically in a live environment. Or we might say this model implicitly depends on the products, our broadband products, for example. And if we change the broadband products, then the model is going to stop functioning properly. It won't stop altogether, so we might not notice if we're not careful, but it's going to start giving wrong answers. And so we can, by stipulating that as part of the policy, we can make that link explicit, and we can test that either periodically or continuously to make sure that the model remains valid in the current environment, and so on. And I'm not going to go through these exhaustively, but you can see the sorts of entities that we're trying to surface, and then think carefully about how we specify those in a way that they remain quite general across all the different sort of types of AI that we might envisage deploying. And then also in release 18.5, we developed this slightly more detailed reference architecture, again, to sort of progress the thinking. And here we're kind of lifting out now the functional elements that we think we need, and we describe the capabilities and the requirements around each of those. What are the tasks that they're performing in terms of providing this governance and management for AI? And at the bottom of the chart, you can see how we've suggested, at least, that one approach is that in terms of wrapping these interfaces around models that will expose things like REST APIs, so lightweight APIs that will allow easy adoption of the TM Forum standards, regardless of who the vendor is or what the technology is. And I think that's quite key, is making all of this practical, so it is actually realized in practice. It doesn't become onerous and a bottleneck. We also recognize that in terms of these functions, a lot of these will be kind of shared across existing components that are part of the vendor solution, for example. But we're trying to make sure we make explicit all of the roles so we can understand where they're being provided and where the gaps are that we, TM Forum needs to step into. And all of this and pretty much everything that's been presented today is documented in the information guide, the snappily titled IG 1184. So that documents all the work that took place in this work stream in release 18.5. So if you want to see that, as a sort of more coherent whole, then please go and take a look and see what we've done there. And of course, we're continuing the work. So for release 19, we're actually drilling down into just starting to implement some of those interfaces in Anger and test them and prototype them. And we're particularly concentrating on those elements that address model provenance across the life cycle. So being able to identify models across the life cycle and tie back to the data and the process that created them. And also that piece around managing them operationally and making sure they're functioning correctly. And demonstrating how we can provide those controls. So that's the focus for release 19. And that's pretty much it from me. So we're almost at the end now where we can take questions, but I'm just going to briefly hand to Aaron before we do that, just to take you through this last couple of slides.
Thanks, Rob and Janki. Great presentation there. Yes, just to remind everybody that a lot more of this and the work that TM Forum's doing can be seen at Digital Transformation World in Nice, which is from the 14th to the 16th of May. Lots of great stuff happening. Where we'll be presenting the latest work, not only in management standards, but across the whole group. We'll have an AI zone there, which is going to be a meeting place for everything around AI, including the AI catalyst that we have, working through a number of case studies, as well as some specific vendors as well. And as I said earlier on, you'll also see the launch of the AI maturity model, which is really exciting. So with that, Mohammed, is there any questions that have come in to you since the presentation started?
Absolutely. Yep. The first question, rather very common. Will the slides be made available after the talk? And I'll probably answer that. We will share the recording of this webinar with everybody who's registered. So yes. The next question here is, can you give us a sense of the scale of AI deployments in a CSP environment?
Okay, well, I can have a go at that, and then I'll hand to Janki if you want to come in, Janki. Well, I think that's quite a broad question, but I'll try and do as well I can. I mean, certainly from my experience from the company that I work for, which is BT, if you talk to my colleagues about AI deployments, they'll say that they've been doing it for 20 years or so. So it's extensive actually in terms of the areas that the technology has been adopted. But of course, I think what we called AI 10 or 20 years ago is maybe not what people are thinking about today when they talk about AI. And I think a lot of the current interest and excitement around AI has arisen largely driven by things like the advances in deep learning. So I think the more traditional AI, and of course it's a spectrum, AI encompasses a lot of different fields, from things like machine vision to the chatbots that we understand, robotics, and of course machine learning, because machine learning is very widely deployed, I would say, and that's a lot of what Janki's demo covered there. But I think the deep learning is much less mature, and so there's a lot more potentially to go wrong there, but albeit coupled with a greater capability. So I think it varies. And that slide, if you remember, I think it was slide 2 or something, was trying to tee up all of the different sort of potential areas that people are looking at. But so I appreciate that's pretty vague, but maybe Janki can add a bit more to that in terms of what you're seeing, Janki, with your interactions with other vendors, other CSPs.
Yes, I think, very correctly, as you mentioned, we've seen, and in my role, I have the opportunity to work with telcos around the globe, and, they are telcos at a variety of maturity levels, and which is, and then we have seen a lot of progression, because I think today we all understand that AI is very important, and it is touching a lot of our lines of business. So as we mentioned, it is important for networks, but not only that, we have started to see, for marketing, AI is being used, and for chatbots, and as we get into 5G, I think both the deep learning aspects of those, as well as transferred learning, and it's just so much happening in this field. I think so it is more, and it depends on, when we say scale, I think the scale is also whether a project, and I really loved the image that Rob, you talked about. What we are seeing is also that a lot of, depending on the maturity and how it is approached, a lot of the times the AI projects are taken as ad hoc projects, and then there is no governance and management thought about in those cases, and then it grows like wildfire, and it's hard to manage it, whether it be small or in scale, a large data set, or deployed on thousands of various small devices, right? So I think what, as part of this this management standards work stream, we are trying to catalog, and as a team of vendors and CSPs, and come together, understand variety of AI models, understand the various technologies, and then coming together to understand in stages how to manage it, right, at scale. So I just wanted to add some other flavor in terms of that as well.
Yeah.
Great, lovely. You mentioned there about AI being used in marketing, Janki, and this next question is related. Can you please share a case study on AI used for marketing operations?
Yes. So, we know, and I've personally worked on a couple of them, in cases where, marketing data can come from, social media is becoming prevalent, and understanding and mining unstructured data, and then trying to understand the voice of your customer, understanding what is resonating, not resonating, and then trying to come up with models around that is, some work done around that, making sure I've shown some recommendation engines where you're trying to understand, where, and they're usually chained models where we see that various inputs coming in from networking data, coming in from credit risk information, coming in from sentiment, all of this feeding into, and then, trying to understand what is the right offer to be made. So, a lot of work being done, and we see AI is becoming critical, right? It's not like, and it has not only to be for a segment, it has to be at a personal level. I need to know that Paul Kelly as an individual. So AI is empowering such things as well. So there are a lot of good studies done. Maybe at some point, and of course, I'll hand it off to Rob as well to share his experiences on how BT is doing that. But IBM has done some IDD studies where we have showcased what is done. I'll be glad to share that with Aaron and TM Forum team so that they can share it with the individuals here. So Rob, would you like to add additional?
Just briefly, because it's not an area I tend to get involved in directly at the moment, but I think and this is also to maybe go back a little bit to the original question about the scale of AI deployments. I think that the thing to remember is that AI, as I said, it's a very broad field, and machine learning is one field within the sort of spectrum of AI, if you like, and then within machine learning, I think you have a variety of different approaches, and you have supervised learning and unsupervised learning, all those sorts of things. But the point being that it's a bit of a spectrum, and I think today a lot of the work around marketing and doing things like building next best action models or doing churn prediction, all those things, they sit very much, I think, in the more traditional machine learning space, predictive analytics, and that's a much more mature space in that area. But Obviously increasingly businesses are looking at the opportunities of let's loosely call it sort of modern AI, if you like, and what new things they're going to be able to do there, and a lot of attention around things like chatbots and how we use AI in terms of improving customer experience, and so on. But I think, from our point of view, in the context of this work, we can sort of think of it as a little bit of a continuum, because a lot of the requirements about doing the former well, in terms of just managing the more traditional machine learning, they flow through into the more exciting end of the space, the newer end with deep learning and so on. If we can't get to grips with things like model provenance and data provenance and things like that for the technologies that we understand, then we're really going to struggle when we start to think about deep learning models and all the issues that arise with those in terms of explainability and adversarial attacks and all those sorts of things. So I think there's a foundational layer, and I see this management piece as part of that. That we're trying to work across those different domains as the maturity grows and we start to exploit the sort of newer technology more.
And I think, Rob, John, give us add. I gave a webinar, the first in the series of these, when we looked at AI-driven 360-degree view of the customer. I think we've touched on a number of areas where TM Forum starting to work on that, and this is building on stuff that Junkie and Rob said. So really, from the marketing perspective that we're looking at is looking at actually how do you unify a lot of ID and get a true 360 of your customer, and using AI to be able to do that. And as Rob says, looking really at the machine learning aspect of doing that, particularly around things such as the social influence analysis. And we've seen Orange have a great case study with their surprise and delight, looking at about the network going down and raising issues and sending proactive messages to customers and finding different ways of doing it. So at the forum, we're looking at a number of ways to do that, particularly around things like propensity to purchase new services. That's a particularly important one for driving new revenues. So we've looked at that, as well as things such as channel deflection predictions. So we've got a number of work happening as well in the customer experience side of AI as part of the forum's work as well.
Great, lovely. So we've got about 4 minutes to go, and I'll probably take 2 more questions. Aaron, probably this one is addressed towards you. Rob did touch on this topic a bit. What is planned for the next cycle, and how can we get involved?
Yeah, so I absolutely would love people to get involved. You can join if you go to tmforum.org, go to collaboration AI data analytics. You can join the projects there. I'll let Rob and Junkie go into the detail of what we're having, but we've got a defined charter already for 19. It's really building a lot, particularly on the work that we've done for release 18.5. We're starting to really distill down some of the issues, look at some specific interface definitions that we're going to be looking at building, looking at some reference implementations, about looking at standards and identifying any gaps that we looked at in the first work, and also quite a lot of work around some of the data model as well, that we need to actualize some of that. So Rob, I'll hand over to you for anything that I've missed there.
Yeah, well, I think you've covered a lot of it, but yeah, so from my point of view, what we want to do in release 19 is get down to actually implementing some of the interfaces that we've identified. So that will be specifying our requirements around them, but also taking that further in terms of actual test implementation, so the proof of concept and prototyping. And as I said earlier, the focus for now is going to be in trying to demonstrate the kind of model identity and model provenance across the life cycle. So because that's pretty fundamental. We want, if we can't track models across from design into production and then retirement, we've got a problem. We're going to really struggle to do anything. So we need to figure out how best to do that. And even something like how to identify a model sounds easy, but it turns out to be, it's non-trivial, obviously. And so we actually want to focus on that and this sort of piece around being able to exert the operational control and tests around models to make sure they're still valid in life, and we get alerts when we need to retrain them, or when they stop performing in the way that we thought they were, or they're no longer compliant in terms of their warranty and so on. So we actually want to build some of that, and some of that's going to be happening in Catalyst projects. So there's various catalysts. I'm involved in one, Janki's involved in one, and so those are opportunities to kind of bolt the management standards piece onto a catalyst project where something is being built, and test the ideas. You know, does what we've specified actually work in practice, or are there some issues that we need to address? And inevitably there will be. And the backdrop to all of that then is the processes that underpin all of this. So we've got members of the team who are working on trying to sort of articulate what the AI management process looks across the life cycle. So that's the kind of foundation, all the technical elements that we focused on today sort of rest upon and try and enable. So it isn't just this sort of free for all. We can articulate this sort of end-to-end view of this is what we should be doing at these different bits of the life cycle, and then point to the interfaces and the APIs as the things that help you realize that. So hopefully that makes sense. I don't know, Janki, if you want to add anything to that.
No, I think you covered it all very well.
All right, lovely. And if you have any questions about joining the particular collaboration program, we will send you contact details with the recording of the webinar. There are a lot more questions up here. We will answer later. We've reached the end of the webinar. Aaron, as a host, any final words?
No, thank you everybody for joining. And as you said, Mohammed, this will all be available on demand. So, and again, any questions, please do direct them to myself, and I can reach out to Rob and Janki for any inputs that we have there. But thank you very much, everybody, and look forward to you joining our project soon.
Yeah, thank you.
Thank you.
Thank you.